Hi everyone, this is video 5 for equations of lines and planes. What I'm going to go through inside this video is a collection of problem types that are confusing, that you don't like. That in truth I don't like either, but we'll go through them anyway. They're famous. I'm going to read it. Find the point parallel equation and point normal equation of the line, so far so good, of the line that contains the point 1, 2 and is parallel to the line with direction vector 5, 6. So you got to read that maybe 2 more times to make sense of it. There are 2 lines here. The line with direction vector 5, 6. I'm going to draw that line. Line L1. So direction vector 5, 6 looks like this. Now I'm going to draw the second line that's here. The line that contains the point 1, 2 and is parallel to that green line. So I'm going to draw that line. That's the line L2. It doesn't matter which one you call L1, which one you call L2. Now what we need for point parallel is point, we have P 1, 2 and direction vector. So let's look at our diagram. We have a line L1 with a direction vector V, 5, 6. We have a line L2 that is parallel to that line. I can use the direction vector for the first line as the direction vector for the second line because those lines are parallel. We can reuse the direction vector from the first line for the second line because both lines are parallel. Thus, here's our answer. X of t equals the point 1, 2 plus t times the direction vector v 5, 6. There isn't anything that we had to do. But look at the next question. So flip back to it. All that's changed is the last part of that sentence. Parallel to the line with direction vector 5, 6 is now parallel to the line with normal vector 5, 6. Everything else is the same. So I'm going to go through the same construction. The line with normal vector 5, 6. So I'm going to draw that vector, or that line. I'm always going to draw my lines going from bottom left to top right, just because it doesn't matter. It's general. So that's my line L1. It has a normal vector n 5, 6. So now that vector goes like this. Okay, and then it says there's a second line that contains the point 1, 2 and is parallel to this first line. So I'm going to draw a parallel line. Line L2. And think about what we need. Needed for point parallel form is P 1, 2 and a direction vector. Which we don't have. We have a normal vector But notice the normal vector for line 1 is the same, or is also a normal vector for line 2. We can construct V by flipping the components and putting a minus sign in front of the other one. We just want a vector that's 90 degrees to the normal vector, which makes a direction vector. So negative 2, comma 1. And there we have it. Thus, x of t is equal to our point P. Oh, sorry. I switched the points of P, not the points of the normal vector n. So that would be negative 6 comma 5. My apologies. So negative 6 comma 5 plus t times negative 6 comma 5. Okay, so 2 examples with different information given. Both lines had the same relationship to each other in both of these examples. But in the first example, we are given the direction vector for the line, for one of the lines, and this example we were given the normal vector for one of the lines. Let's see what happens if we change something else. Now we're given part of the same setup. We're asked to find point parallel equation of and point. Oh, I forgot the other pieces. Point normal. Okay. I'll just put the answer underneath. And n so our normal vector n is negative 6 comma 5. So negative 6 comma 5 dot x minus 1 comma 2 equals 0. Almost forgot the second part of the question. Find the point normal equation of the line. So that's the point normal equation of the line. We need the point normal equation for this line. We already have n. And so our n was 5 comma 6 dot x minus 1 comma 2 equals 0. So it gave us the normal vector, gave us the point, we just plugged them into the formula. The work was necessary for this problem for the direction vector. Now in this one we're going to do the same thing, except look what's happened. The relationship between the lines is different. The second line is now orthogonal to the first line. They're 90 degrees to each other. So I'm going to draw that first line. The line with normal vector 5 comma 6. Oh, not yet 3D, not yet. So that's our line. I'm going to draw in a normal vector. N for that first line. Now I'm going to draw the second line. This is an orthogonal line to L1. Okay. So n is 5 comma 6. Let's get the direction vector for the line by flipping the components. So v is negative 6 comma 5. Let's label the new line now. I'm going to label a normal vector M and compare the direction of the normal vector for the green line to the two vectors for the orange line. Notice that M is pointed in the same direction as V. So I'm just going to recycle V. I'm going to use V, the direction vector for the first line, as the normal vector for the second line, because these lines are at 90 degrees to each other, and I can do that. So M is -6, 5. I'm also going to label the direction vector I'll call it U, is in the same direction as the normal vector of the first line, so 5, 6. So first, point parallel. We have x of t so that green line is our goal. We want a set of expressions that describes that green line. We want find the point parallel equation and point normal equation of the line that contains the point 1, 2 and is orthogonal to the orange line that we drew. So x of t equals p plus t times u So p is 1, 2 plus t times 5, 6. And point normal, n, it's not n, it's m, just to be consistent with my picture. Dot x minus p equals 0. So m was -6, 5 dot x minus 1, 2 equals 0. Then that would be the answer for this one. And there's more varieties. Like instead of being given a normal vector for this first line, we could have been given the direction vector. You may find the weird diagrams online for how to solve these, like if this then that, like tree diagrams. Please draw it. Drawing it is far simpler than memorizing or working with these massive tree diagrams that explain all the different combinations of orthogonal lines that are perpendicular to the orthogonal line with the parallel. Like it gets super confusing. Draw what you're given and then try to answer the question that way. And I'll continue in the next video because these are kind of their own thing.